This one wants to know how many formula units are in 6.5 moles of sodium sulfate. Okay, so sodium sulfate, that's going to be a metal plus a polyatomic ion. So that's definitely going to be an ionic compound, right? So sodium sulfate is ionic, and so a formula unit is the representative particle. So we're going to be able to use the 6.02 times 10 to the 23rd representative particles. And it's also saying moles, right? So formula units in moles are our 2 units. So with moles, we're going to use the 1 mole. All right, so let's set this up. I'm going to have 6.5 moles of sodium sulfate. To save me a little bit of writing, let's go ahead and figure out what the formula for sodium sulfate is. Sodium is in the first column, so it's got a charge of +1. Sulfate's one of the polyatomic ions we've been working on memorizing, so that's a 2-. We're going to have to crisscross, and so we're going to bring the 2 down on the sodium. We'll bring the 1 down on the sulfate, so that doesn't change anything. So we're going to end up with Na2SO4. So we've got 6.5 moles of Na2SO4. We're going to place that over 1, and then we're going to multiply that by, well, in this second conversion factor, we're going to take the 2 things out of our mole triangle that's written down at the bottom. We're given units of moles of sodium sulfate, so we want moles of sodium sulfate to cancel out on the bottom. And we're asked to find formula units of sodium sulfate. So we'll put what we're trying to find on the top. And now let's grab our conversion factors. We've got, for the bottom with moles, we've got 1 mole. And on the top, with representative particles or formula units, we're going to add in 6.02 times 10 to the 23rd. Right, I said add in the sense of writing it in, not in terms of the math, because the math that we're doing here is all multiplication. Notice I've got 2 1s on the bottom. I don't have to multiply or divide by 1s because doing that doesn't change the value any. So I'm just going to run through the math on the top. I've got 6.5 times 6.02 EE23, enter. And that's going to give me 3.913 times 10 to the 24th formula units of salt. And so how did I get formula units? The moles of, I'm sorry, and it wasn't table salt, it was sodium sulfate. The moles of sodium sulfate cancel out because that's what we're given, and then that's on the bottom of our conversion factor. That leaves behind formula units of sodium sulfate for the unit. One last thing I have to do is clean up significant figures. Notice that the number we were given, 6.5, that's only 2 significant figures. And so that's going to limit our answer to 2 significant figures. So we're going to round that to 3.9 times 10 to the 24th formula units of sodium sulfate. So that was part A of number 2. Let's take a look at part B. This time around, the question's asking how many atoms of oxygen are in 6.5 moles of sodium sulfate. Okay, well this one's a little tricky because atoms are not the representative particle for sodium sulfate, right? We said that sodium sulfate was Na2SO4, and its representative particle is a formula unit, not an atom. So we're going to actually have to do this with an extra step in our conversions. We're going to start the same way. We're going to take our 6.5 moles of sodium sulfate and place that over 1. We're going to multiply by a conversion factor where we're going to put moles of sodium sulfate in the bottom. And in the top, well, let's take a look at what our choices are, right? We can do moles with the numbers off of our mole triangle by taking 1 mole and placing that down here at the bottom, but that's going to link us to 6.02 times 10 to the 23rd representative particles. And for sodium sulfate, that representative particle is a formula unit. So it's a formula unit of sodium sulfate. So we've got to do one more step here to get to oxygen, which says that for every 1 formula unit of sodium sulfate, there are 4 atoms of oxygen, right? We're just getting that from the formula for sodium sulfate. Within sodium sulfate, there are 2 atoms of sodium, 1 atom of sulfur, and 4 atoms of oxygen. And oxygen's what we're looking for, so that's the one that we're going to grab here. If I'm going to run this in my calculator, notice I've got 3 1s on the bottom. I don't have to divide by any of those because dividing anything by 1 doesn't change the value any. So what I need to do on my calculator is 6.5 times 6.02 EE23 times 4. And that's going to give me an answer of 1.5652 times 10 to the 25th. In terms of units, the moles of sodium sulfate canceled out, and formula units of sodium sulfate canceled out as well. And so that's going to leave me with atoms of oxygen. In terms of sig figs, our initial number only had 2 sig figs, so we're going to round that to 1.6 times 10 to the 25th atoms of O. Now, I often get questions in class when we do something like this as to why we went with 2 sig figs from the 6.5 and the 4 atoms of oxygen looks like it has just 1 sig fig. But this is what we consider to be an exact number or a counted number. If you can reasonably count something without making a mistake, or another way of looking at this is that it's a defined number. We're defining the sulfate polyatomic ion as having exactly 4 oxygens. So with numbers like that, there is no uncertainty. There are exactly 4 oxygens in 1 formula unit. If there's no uncertainty, significant figures don't apply. So the numbers that it would matter for are going to be that 6.5 moles. So we're going to round our answer to 2 sig figs, just like the 6.5 moles have. Atoms can be tricky. People see atom and they immediately say, oh, we're going to use Avogadro's number. But remember, it's got to be your representative particle. If you have a pure element and the atom's the representative particle, great, it's all good. But typically with something like sodium sulfate, what we're going to end up saying instead is something like 1 formula unit of Na2SO4 is equivalent to 2 atoms of sodium, or that it's equivalent to 1 atom of sulfur, or it's equivalent to 4 atoms of oxygen. And it's that second step that's going to get us all the way to atoms. All right, our next example. If a solid gold ring weighs 2.1 grams, how many atoms of gold are in it? Well, this is our first one today with grams. So let's take a look at how we're going to handle that. We want to take our number, our unit, and our chemical to place over 1. To get our chemical, we got to read this and go back and realize they're talking about gold. So this is 2.1 grams of gold, and we're going to place that over 1. That's what we're given. And now we need to set up a conversion factor based on the numbers in our mole triangle. And since we were given grams of gold, we need to put grams of gold on the bottom of the next step. And we're asked to find how many atoms that is. So when we get to atoms, that's always a little bit tricky. We want to make sure that atoms is the representative particle, and if it's not, we have to go to the representative particle first and then go to atoms. Well, in this case, gold is an element, so an atom is its representative particle. So we can just go straight to atoms of gold. And so when we look, let's see, and atoms is our representative particle for gold. And so when we look at our equivalents down at the bottom, where it says grams, we're going to look for the molar mass. So I'm going to go to the periodic table, and I'm going to find gold in the periodic table, and its mass is 196.97. So that's what I'm going to write down here on the bottom, 196.97. And up in the top, we're going to put Avogadro's number, because the representative particle for gold is atoms. And so I'm going to write in 6.02 times 10 to the 23rd atoms of gold. So now we're going to have 2.1 times 6.02 EE23 and divided by 196.97. And that's going to give us 6.4182 and a bunch of other digits times 10 to the 21st. For our units, grams of gold cancel out with grams of gold. That's going to leave us just atoms of gold for our unit. And if we look at what we were given 2.1 grams. That has 2 sig figs. And so that's going to limit us. That's the smallest number of sig figs we're looking at. And so that's going to limit us to 6.4 times 10 to the 21st atoms of gold. It gets messy when I write with my stylus on a tablet. So just want to highlight there, that was our final answer. All right, let's look at our next example.